Hello, AE7TO here, and I'll be using this video to describe how to install and configure HF Sounder, which is a Java-based utility for finding an optimal frequency between two amateur radio HF sites. Before I get into details of the software installation and configuration, let me emphasize the role for this software in amateur radio. This slide depicts a propagation prediction between two sites, in this case a couple of 100 miles apart in Oregon. And when you look at the circuit reliability diagram here, you can see that depending on the time of day, this is Zulu time of course, sometimes the 60 meter or 5 megahertz band is more likely to work between those two sites, and sometimes the 80 meter band or the 3.5 megahertz band is more likely to work. And there are these transition intervals where you're going to be switching from one band to the other. And then of course the 40 meter band may, because the ionosphere doesn't always cooperate with our predictions, there may actually be times when the 40 meter band is better. So the fact is, even when you have good data fed into your model, when you get out there on the scene and you use real antennas over real ground, you may actually have conditions that don't quite match the predictions. Well, if you don't have communication between the two sites and the planned frequency is not working, what do? You could try the alternate frequency, but if you don't switch at the same time as the other station, then you're going to chase each other all over the spectrum and never be able to communicate. You could attempt to communicate between the two sites using satellite phones like the Garmin InReach, but that's a little bit of a waste of that precious resource, and even then you're just going to be using trial and error and trying to coordinate it manually. So the purpose of HF Sounder is to automate this process, and the way it works in a nutshell is that one site designated as the remote site will transmit on each of 5 frequencies with 1 minute allocated to each frequency, and then it'll go into listening mode, and during the second 5 minutes the net control station will send a message back to the remote station saying, this is the frequency where I saw the best signal to noise ratio, so this is the frequency we're going to operate on. And both stations hop between those 5 prearranged frequencies according to the same schedule, so that they're always either transmitting or listening on the same frequency. And we'll see more of that once I get into the software itself. So I will minimize that and take you into the software itself. Before I get into HF Sounder itself, I should emphasize that HF Sounder actually works in conjunction with Fldigi, which is something most hams are probably familiar with if they do digital modes. You should be able to see it on your screen right now. And in addition to installing Fldigi, you need to make sure it works with your rig. Make sure rig control is functioning properly. Make sure the sound card is configured correctly. Make sure your levels are adjusted properly on your sound card, because HF Sounder won't do any of that for you. Fldigi has to be working with your radio and with your sound card before HF Sounder can do its work. There are some additional settings in Fldigi that I'm going to zero in on and make sure that you understand how to set them so that it'll be compatible with HF Sounder. First of all, I already mentioned sound card. I'm not going to go into detail on that, but in your I/O tab of your Fldigi settings, there's something called XML RPC, which is an application programming interface between Fldigi and other programs like HF Sounder. You need to make sure that you make a note of what port it's listening on. The HF Sounder software assumes that you're going to start with 7362, which I believe is the default for Fldigi's XML RPC interface. Just check that and make sure it matches between Fldigi and HF Sounder, because if they don't match, the two won't communicate. Another thing that you're going to want to set up is PSM. That stands for Power Signal Monitor Button. And what that's used for is to inhibit transmit of whatever's in the transmit window if Fldigi detects that there's another station on that frequency. The advantage of that is this automated software is going to attempt to transmit these sounding messages, and if there's another operator using that piece of the spectrum and the control operator doesn't happen to notice that, Fldigi will automatically not transmit until the channel is clear. So that's the other key thing. In addition to enabling it, you're going to probably want to uncheck CSMA. That's not really necessary in our situation. And then it's a good idea to check this, because that causes this control button to show up in your main window. So all those settings are already enabled in Fldigi. Another thing you need to make sure of in your Fldigi setting is that this offset within the audio passband matches at both ends so that they can see each other's signals in the waterfall. So Fldigi, if you don't already have it, you can find it in SourceForge. Just Google Fldigi, you'll find it, download it, install it. It runs on Windows or Linux or Macintosh. HF Sounder is also available on SourceForge. And make sure you also install the Java Runtime environment, version 8 or newer, because this Java utility will not run without Java Runtime also installed. You should also be able to, because it is Java, you should also be able to install this in Linux or a Macintosh environment. So once you launch the jar file, and there's actually two jar files, one is named all-in-one. I've renamed it to HF Sounder All. The other one is called hfsounder.jar. The difference between the two is that all of the library files are embedded in this all-in-one jar file, and if you're going to use the other jar file, you have to make sure that that lib folder is available so that those additional runtime libraries are available. Once you launch it, you get this little disclaimer window here warning you of your responsibilities as an operator, to look out for safety, to monitor the operation of the software at all times, to protect your own transceiver by watching for SWR. If for some reason your auto tuner does not work, you're going to want to stop transmitting using the Fldigi controls. If it's a tune, you can uncheck this button. If it's a message transmission, you can toggle this button in order to stop the transmission until you troubleshoot your auto tuner. Obviously, you want to keep bystanders away from your antennas. You'll also want to stop a transmission if the frequency is occupied and Fldigi PSM feature does not do it for you. What I found in testing is that the PSM feature will prevent a transmit of the message that's in this window right here, the transmit widget, but the PSM feature will not disable the automatic tune. So you may have to do that yourself if you find that the frequency is already occupied. And then the other key warning you see here in this initial log window here is that you need to make sure that these frequencies configured in HF Sounder match for all of the stations in the net. So let me walk you through this settings window that pops up as soon as I launch the jar file. First thing you're going to want to set is your call sign. And this does override the call sign that's configured in Fldigi. So this is the call sign that will be transmitted with your sounding messages, regardless of whatever you might have configured in Fldigi. You want to set your mode. I'm going to set this station's mode to net control. The other options are remote site and listener. I'll explain the differences. The remote site is the site that transmits sounding messages during each of the first 5 minutes of the 10-minute sounding period, and then it goes into listening mode for the second 5 minutes. The net control listens for the first 5 minutes for those sound messages from the remote site, and then makes a selection of a band to operate on, and then sends a response back to the remote site saying, essentially, use this band for operating. And then once the remote site receives that from the net control, both stations can switch to that band and begin operating. The listener mode is in case you have a third, fourth, or however many additional stations, they can simply listen to both the remote site and the net control, and then once the net control announces the operating band, all the listener stations can join in the net by switching to that same band. This next portion of the setting window has to do with starting the setting the start time. This is when the scheduled sounding sequence will start, either AM or PM, whatever hour of AM or PM, and then whatever 10-minute time slot you're going to want to use. So let's say the agreement is you're going to get on site, set up your rigs, your antennas, your power, and then be ready to operate by 9:30. If that were the case, you'd probably check the 9:30 AM button, the 9 button, and the 30 button in order to commence operating at that time. In my current situation, it's actually 17:30 local time. So I'm going to go ahead and set this to PM, and I'm going to give myself lots of time. So I will set this to 1800 local time, because by then I should be ready to actually do a test. This this checkbox right here is for the purpose of scheduling a sounding sequence after the date changeover on the local system. Which brings us to the issue of time zones. You can set your system time to Zulu time or local time, take your pick. Just make sure that all the stations in the net use the same time frame in order to make sure that the sounding sequences are coordinated at both ends. So if this station is going to be set to 1800 Zulu time, you need to make sure the other station kicks off the sounding sequence at 1800 Zulu time. This next portion here is devoted to configuring your frequencies. You can choose any 5 frequencies in the amateur bands that you want. Right now I've got these default frequencies from each of 5 separate amateur bands, the 80 meter band, 60 meter band, 40 meter, 30 and 20 meter bands. You may actually in many situations decide that you only need, say, 3 of those bands. Let's say 80, 60 and 40. You don't need 30 perhaps, you just don't need 20. What you can do if you don't need 5 different bands is take some of the more popular bands and have more than one frequency configured from that popular band, like 40 meters, which is very busy these days. You may want to have a primary and a backup 40 meter frequency so that if one is busy during the sounding sequence, you can all go ahead and sound on the other one. The key thing to remember though is that whatever 5 frequencies you choose must be configured on all stations in advance of departing for their operating sites, because once they're out there you're not going to be able to communicate a band change to them unless you're able to get on a satellite radio or some other means of getting that word to them. These buttons here are for the purpose of previewing some of these stations. So if I click on this button, for example, you can see that my station has just switched to that frequency, and I'm able to see that there's no traffic there right now. I select this button and I can see that that 60 meter frequency is also available. I click the 40 meter listen button, switches to 40 meters, and fortunately that's still free. I switch to 30 meters and we're probably okay, at least in that narrow little window that we're going to be transmitting on. And then lastly 20 meters. And there may be something going on there. It looks like some kind of very broadband digital mode. And I'm not that optimistic that 20 meters is going to work. So if I were the remote site, I could go ahead and decide not to enable that band, and then I would rely on one of the other 4 bands to be available. And for an NVIS mode, for example, you probably wouldn't be able to use 20 meters either anyway, so I'll go ahead and disable that. You should have figured out by now what the band enable buttons are for. It allows any station to decide not to use one of the sounding bands, and it will not transmit on that band. In fact, it won't even listen on that band if you uncheck that button. This next row of checkboxes is the transmit tune tone checkbox. If you have an auto tuner and you want Fldigi to transmit a tune tone, it's the same as clicking this button in Fldigi in order to trigger an automatic tune, then that's what you would use these buttons for. By default they're checked. Usually you're going to want to go that route. And it's also a good idea to go ahead and train your auto tuner in advance so that it can perform a very rapid memory tune once you're actually doing the sounding sequence. So you could click each of these listen buttons in sequence and then do an Fldigi tune in order to store the settings in your auto tuner's memory, so that once you're in the sounding sequence you don't need as long of a tuning sequence. Which brings us to this little button here, or this little setting, which is the tune duration in seconds. I know that my auto tuner, if I have already trained the tuner to each of the operating frequencies, that it needs less than 5 seconds to perform a memory tune, so I'm going to change that to 5. This is the Fldigi listening port that I showed you earlier for the XML RPC listening port. And by the way, as I hover there, you'll see the little help text that comes up. If you forget any of the explanations that I've offered for these settings, there's a help text that will pop up when you hover over each of those settings. This sounding text field right here is to be filled with some brief text that is used to identify the sounding transmissions to all stations in the net. You want to keep it brief because if it's too long, it'll get garbled in some cases by weak band conditions, and then the sounding will not be recognized by the stations, and you'll have a failure of the software to recognize that that was a sounding transmission. So keep it short and keep it identical on every station because, again, if it doesn't match, this is the message that each station will listen to, and if it doesn't see this message, it'll ignore the sounding. This free text field is where you can put some brief message that can also be appended along with the sounding text and your call sign to each message. And this is the one setting out of all these settings that you can actually alter after you save your configuration. If, for example, the net control station wants to send a brief text message, some coordinating instruction in addition to commanding a switch to a given frequency, you can put that text in this field and then it'll be sent. So this station that you're looking at right now is going to be the net control. That's going to be the call sign. It's going to kick off at 1800 local system time. I've already synchronized the clock at both stations. I'm going to stick to these default bands. I'm going to disable the 20 nanometer band. And that's the text I'm going to send. It's a little bit redundant, but I'm identifying myself as net control, and I'm going to go ahead and save these settings. And then what happens is the actual operating window kicks off, and I'm going to go ahead and start, which actually schedules all of these events in the system scheduler. What you see here in this window, first of all, is a scheduled start time in case you forgot what you configured it for. This is the current status. It's currently waiting for the next scheduled event. And then across this row, you see each minute after that starting time. The first minute, this station will be listening. The second minute, net control will also be listening. The second, third, and fourth minutes, the net control station, identified right here, will be listening during those first 5 minutes. Then, based on the signal noise ratio heard from the remote station, the system will automatically select one of these radio buttons, and that will be the time slot where the net control station will send this sounding message back saying, let's use this band. If you uncheck this automatic box, instead of the software automatically choosing the band with the highest signal noise ratio, you as the operator have to make that choice. And you have to make that choice quickly because right after this remote site transmission time slot ends, the software is going to look for one of these radio buttons. If it doesn't see one, then it's not going to know which band to transmit on. So again, second 5 minutes, 5, 6, 7, 8, and 9th minute, these little fields tell you what's going to happen for this net control station during that time slot. And instead of listening like it does during the first time slots, it'll either wait or transmit depending on which radio button is selected up here. So the net control station is ready to go. I'm going to minimize these windows, and I'm going to go ahead and configure the remote site. I've got a remote desktop session at the other end. I'm going to go ahead and launch HF Sounder at that end as well. I'll move this little warning window out of the way. I've got to set a call sign here. By the way, these settings will be saved in an ini file after you do your initial configuration, so that you don't have to make these frequency choices or the call sign configuration, everything every time you launch the program. I want to again synchronize the start time, so I'm going to go with 1800 local time. This is the remote site. I've set the call sign. I'm going to leave the bands all the same. I'm going to disable this one at this end as well. And I'm going to go ahead and put a little free text in there just for fun. And I've done memory tunes on this station as well, so I'm going to set my tune duration to only 5 seconds. I can now save that. Again, I've got a window pop up. Note the lack of the radio buttons for band selection here. That's because this station is going to transmit on every band and then listen on every band. It doesn't need radio buttons because it's the net control station, not the remote site, that's going to make the band choice based on the signal noise ratios heard from the soundings. So I click Start, and now this station 2 is waiting for the next scheduled event. So what I'm going to do is arrange these windows, get them out of the way, and then I'm going to terminate this video because we have 20 minutes and I'm not going to make you wait that long, and I'll have another video where you can actually see the software go through a sounding sequence. AE7TO signing off for now, and again the next video will show the software actually doing its job.